to talk about Python and how we can debug Python code for mere mortals. My name is Mark Baggett. I'm a senior SANS instructor, and I'm the course author of SANS SEC 573, Automating Information Security with Python. So, just to get a couple of things out of the way, today we are going to be talking about a topic that somewhat assumes that you know some Python code. Now, we're not going to go in, off the deep end and talking about really advanced subjects. If you don't know Python, I hope that you'll still be able to get something out of the webinar, but the fact is that I am going to make some assumptions that you'll understand some of the code on the screen as we go through and start talking about how to debug the code. Now, this is much different from the 573 course that we teach. SEC 573, we don't assume any prior knowledge when you come into the class. So if you'd like to join the workforce of people that are using Python or just coding skills in general to fill this huge skills gap we have in the industry of finding people who can create tools that will automate their jobs and allow them to focus on the more difficult challenges that we have in information security, then check out my course, SEC 573. It's running in Orlando this year in April, and of course it is available on demand. Just kind of quickly give you an idea of the kinds of things that we talk about in the class. As I said, there is no assumption that you know Python coming into the course. Days 1 and 2 of the course does talk about the essentials of coding. If you've never done any coding before, we're going to introduce you to those coding concepts and get you up and running where you can develop code. Then on days 3, 4, and 5, we will look at applying those Python coding skills in different areas in information security. So day 3, we focus on developing defensive projects. Day 4, forensics, and day 5, offensive focused projects. Now, this isn't written such that if you're an offensive person that days 3 and 4 aren't of any use to you. In day 3, we talk about opening files, parsing through large sets of data in order to use regular expressions to find useful pieces of information like IP addresses and analyze large volumes of logs in order to find evil in them. On the forensics day, we talk about pulling apart binary structures and looking for pieces of forensics artifacts that are embedded within them. So every day, you're still learning skills that are applicable across the entire spectrum of information security. Just we have projects that focus or are themed after one or particular vertical in the information security field. And then, of course, day 6 is our capstone event where we have Capture the Flag. And also running days 1 through 5 of this is what we call the PyWars Challenge and Capture the Flag. See, if you come into the class and you already know the essentials of days 1 and 2, then I didn't want to have a class that you wouldn't be learning from in days 1 through 5. So we have PyWars that runs for the length of the course. And PyWars allows us to run in a self-paced training environment. So I give you all of the labs up front, and you take every single lab that's in the book home with you at the end of the course. So if you're unable to complete a lab during the course, you'll still have that lab material when you go back home. And people who are brand new to coding, when they come to the class, they'll usually finish about 50% of the labs, 33 to 50% of the labs during the time that's allotted in class. So what you see here is a kind of an overview of general study plan for people who have never done any coding before. On day 1, they'll finish challenges. They'll finish about half of the challenges that they're supposed to, or that were given to them on day 1 and day 2. Now, there are some challenges in there that they will never finish that are part of the Capture the Flag challenge. So there are questions that are mixed into the lab environment. They're there specifically for the advanced users that are related to given topics. Now, advanced users, people who already know Python coding when they come to class, generally accelerate through the labs. So on day 1, they usually will have finished all of the material associated with day 1 and 2 by the end of day 1. On day 2, they begin working on challenges associated with day 3. Day 3, they're working on day 4 challenges, and so forth and so on. And most people who already know how to code can complete all of the PyWars challenges in days 1 through 5, but I've never ever had anyone finish all of the labs that are in the class. Most of the people who finish all the PyWars challenges end up skipping the labs that are not part of PyWars, that are part of days 1, 2, 4, and 5. They'll work through additional, they won't work through those additional labs, they just spend all their time on PyWars, which means when they go home, they'll still have additional lab work that they can work through to continue to build their Python skills. And this, the additional challenges that we have in there are put forth as a capture the flag. So if you came to the course already knowing how to code in Python, really the first 5 days of this course are a capture the flag event for you. And the first person to complete all the PyWars challenges in the course receives a capture the flag coin for doing that. But most people who come to the class finish I'd say 80 to 90% of the labs during the time that they have in class. They'll take the additional labs home with them and either finish them at night or when they get back to work. And in working through all of the labs, you have a good set of skills that you'll be ready to challenge GPYC exam, which is the certification that goes along with this course. Now we're here to talk about debugging Python code. And usually,
hey Mark.
Yes.
Yeah, you have the audio is still breaking up. Is it possible you have Dropbox or Google Drive or something in the background that is syncing?
Nope.
Could be causing.
Nope, I got nothing in the background.
All right. Continue and we'll see if it improves.
Okay, well, I'll pause some unnecessary VMs here that are VMs that I would have liked to have shown, but we can see if this helps at all. Okay. I really don't think it's an issue on my end. I've got nothing going on here, but let's talk about these tracebacks and debugging Python code. Normally, if you have to debug a Python program, it's because you've seen one of these on your screen, right? It's the traceback. This is the standard format of errors that occur when the Python programs crash. And there's a lot of information that you can gain by just reading the traceback. If we look at this traceback on the screen, we can see the names of the functions that are being called, the lines of code that are causing the error, and the names of the error that occurred. Now, when you read a traceback, you start at the bottom. So unlike normal reading where we read from top to bottom, when we're reading a traceback, we read from the bottom to the top. So the first thing I would start with is this last line, and here it's labeled line 1. And here we can see we have an unbound local error, colon, and then a description of this problem. Now, unbound local error is what Python considers this error. And then the thing that follows is a description of it that's related to my program. And it tells us that the local variable called computer choice was referenced before it was assigned. And this is considered an unbound local error. The question that I might ask is, okay, this variable computer choice is being referenced before it was assigned. What line of code in my program, or where did that happen? If I want to know where it happened, I can look up one line. So this line 2 here in the traceback is where it said, I see the line of code in the program where this error occurred. And here I can see it says, return computer choice. So this call to return computer choice on line 2, at that point, this was accessing or referencing the computer choice variable before it was assigned. Well, where is this line, return computer choice? I can look up one more line. And on line 3, I can see that that is inside of the file debugme.py, and it's on line 16. And on line 16, inside of debugme.py, is this line of code, return computer choice. And it is inside of a function named myChoice. So the output here tells me the name of the file, the line it's on, and then if it's in a function, the name of the function that it's inside. So inside of this function myChoice, we have return computer choice. Well, where in my program did I call the myChoice function? I can look up one more line, and here I can see C equals my choice choices. And what line of code is that? I look up another line. I can see that that's on line 37 inside of my program, and it's in module. When you see module there, you're in the main part of the program, the main body of your program. So by just looking at this traceback, I know that there's a computer choice variable, that on line 16, there's a reference to computer choice. That is inside of a function named myChoice, and myChoice was called here on line 37 inside the main program. So this traceback gives you a lot of useful information. Now, when it comes to debugging this, there's three typical ways that you go about debugging these things. There's the not so powerful way of just adding print statements to your program. There's the very, very powerful but very advanced way of using set.systrace to add code to do some debugging to your program. And then there's the happy medium, which I think is what mere mortals are going to be using, which is using pdb.py to use settrace and make your life easier. So let's just look at these three methods and see how we could use them. I'm going to switch over to a demonstration VM. I'm going to log in here. And in here, I've got a couple of different programs. Now, I'll make these programs available to you for download if you want to use these programs. Just follow me on Twitter at Mark Baggett. I'll follow you back, and then I can DM you a location where you can download these files or transfer them to you some other way if you want to walk through these demos on your own. But let's just look at this program, debug.win. So I'm going to run it first to see what it does. Python debug win.py. I can see that it prints lose, 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 win, win, lose, win, and it tells me that I won 3 times. All right, let's run it again. I won 4 times this time, and so what's going on here? Well, let's take a look at the program. Let's gedit debug me or debug win.py, and I can see that I've got a little Python program here that we use the future module to make this compatible with both Python 2 and Python 3. We use the random module, which is going to allow us to pick random values. And then we've got a function called my function that takes in a loop count. Here at the bottom, we call my function and we pass it the number 10. We're going to capture the value that it returns into a variable called total. And then it says you won that number of times. So what does my function do? Well, it initializes this variable win count to be 0. And then for however many times you passed in there, so in this case 10 times, it's going to do all of the things that are embedded beneath this for loop here. And what does it do? Well, it's going to choose a random name from this list of names. And then if the name was Mark, it's going to print win, and it's going to increment our win count. And otherwise, it's just going to print lose. And then finally, it returns the win count. Okay, now, there's a couple of things that we can learn just by looking at this, and probably the most significant is that I'm obviously the type of person who makes himself feel better about himself by making him win and everyone else around them lose. But that's not that important. More importantly, we can learn that this program is choosing a random name and then counting how many times it's Mark. Now, I can look at the program and figure that out. If I wanted to, I could also come in here and add some print statements. So I could come in here and I could say, let's print the name is, and then the name. And I'll save my program, and then we'll run the program again. Let's get out of gedit. And I can see that by adding print statements here, that I can track the values that are being assigned to variables inside the program, which will give me a little more insight as to what's going on inside the program. So adding print statements is one way that I could watch a program execute and get some insight as to what's going on. Another way we could do this is we could use sys.trace. So inside of Python, if I import sys, and I get some help on sys.settrace. Sys.settrace is a function that's built into every Python interpreter. And what this allows you to do is to define a function that's going to be called every time that there's a function call in your program. So this is an integrated debugger that's part of the Python interpreter. And so I can create a function and call sys.setTrace, and it will call that function on my behalf. I've actually already written a little bit of code here to take advantage of that here. So this is my same win program, and I've got my function loop, and I haven't modified this code at all, but what I've done is I've created a function called trace calls. And what this function does is it's going to take the information that's passed to it when I call sys.setTrace, and it's going to print out some of the values there. So it'll print out the name of the function that's being called, the line of source code that it's on. And it will also print out the file name that it's a part of. Now, if this first function returns another function, in this case it returns a function called traceLines, that traceLines function is called for every line of code that executes in the program. So let's watch what happens now when I add these two functions and then I call sys.setTrace right before I call tote equals my function. So let's actually leave this open so we can see it. And over here, I'm going to Python, and we'll run it with Python. We'll run it with Python 2. Debug Win Debugger. Okay, let's run that again and pipe it through less so we can see one at a time. So the first thing that happens here is it has the call to my function on line 5. So we did our sys.setTrace, and then it calls my function. And now it's showing us that it's calling my function in line 5. And then it gets into line tracing. Here in the line tracing, it's telling us that it's on line 6 inside of my function. We're inside of this file that's on the hard drive, and it shows me all of my variables that are set. So here I can see that the variable loop count has a value of 10. And in here, here's my variable loop count. We just called it, passing it in a 10, so loop count has a value of 10. Then it's going to execute line 7. And on line 7, here, I is initialized to count from 1 to 10. And so here on line 7, on line 6, we set win count to 0, and on line 7, we set I. So here we set win count on line 6, and here, after line 7 is executed and we're now on line 8, I can see that I has a value of 0, and win count has a value of 0. The next thing that happens is when line 8 executes, it calls random.choice, and it's going to choose one of these names from this list of names. And inside my debugger, I can see that it says I'm now calling the choice function inside, which is on line 273, inside of random.py. And it steps in, it shows me, all right, this is what's on, I'm now on line 275 in that function. And here's the variables that are set, and then 275 executes, and it returns, in here in the event, you can see that it returns a value of Bill back from that choices function. So use my down arrow, we'll watch a little bit further, and now line 8 has finished executing, and so now we're on line 9 in our program. Now you can see the name variable the name, which was assigned by calling random.choice, has a value of Bill. And I can continue to step through this just by adding these two functions and a call to sys.setTrace. I can add debugging code directly to my program, and it'll allow me to step and watch every single line, not only in my code, but also into the modules that are using it. So here I stepped into random.py and was able to watch that code work as well. Now, you can do this, and this is actually a very functional, like as long as you can get in and experiment with these frame objects. Each of these functions takes in a frame object, an event, which is either a call to a function, a line, or a return value, and then arguments that are associated with that event. I need to pull these things apart and pull the information out of it that I want. And in this case, you can see that I'm pulling out some line numbers and file names and things like that. But as long as you can step through and look at these things, you could create a very powerful tracing program. Now, this might be very useful. Perhaps you wanted to just run a program and watch every single function that's called, but you didn't necessarily want to step through it with a debugger. This would be a great way to do that. But I think that this is really a more advanced way of debugging your code, and it's not quite as functional as just using Python's built-in debugger to do it. So let me get out of this. Let's talk about PDB, Python's built-in debugger. So there's three ways that we typically start debugging a program. Okay. One of them might be if I had a large program and I wanted to watch it begin executing at a certain spot. What I could do is I could gedit debug TicTacToe, and let's say that I wanted to just watch this user turn function execute. What I could do is I could come into this program and I could go to the point where I want to begin watching the program, and I could import PDB, which is the Python debugger, and then I could call pdb.set_trace. By calling setTrace and saving the program, now I can just run that program. And it begins executing, and as soon as it hits that line of code, it drops me into the Python debugger. And here you see my prompt changed to PDB. Inside the Python debugger, I can do various things like hit question mark, and it'll give me a list of all of the different commands that are available to me inside of the Python program, inside of the Python debugger. A very useful command is the command list. List will list your code, and when it does, it puts a little arrow here on the left-hand side that shows you what line of code it's about to execute. And in here I can see that it is currently on line 69 and it's about to execute this while true statement. So the adding import PDB and a pdb.setTrace will allow you to add code, and when that code is executed, it'll stop the program's execution and drop you into a debugger. Now let me remove that line of code from this program. I want to show you another way that we could start the debugger. Another way we could do this is I could type Python -m pdb and then debug TicTacToe.py. And what this will do is it will run the program PDB and then pass TicTacToe as debug TicTacToe as the argument. Well, what is this -m command line option on Python? I'm sure you've all seen it before. You've probably seen on some of SANS' awesome posters, Python -m simple HTTP server sets up a web page. Well, what does this -m option do for Python? Well, Python has a path, just like the Linux terminal and Windows command prompt has a path. Python also has a path. If you want to see what its path is, I can do a Python -c, import sys, and then I'm going to print sys.path, close parentheses, close quote. And here I can see a list of all of the directories that Python looks through when you import a module. So when I type import and then give it the name of module, it goes into each and every one of these directories to see, does that module exist? And that's how import finds things. Well, if I want to run something and I know it's in one of these directories, I can say Python -m, give it the name of the program that's in one of those directories. In this case, I'm giving it the name of the program pdb.py. And then I'm going to pass as an argument to PDB the name of the program that I want to pass. So that -m, really all it says is I want you to run pdb.py, which exists inside of one of these directories. And so it'll go through those directories until it finds pdb.py, it executes that program, and it passes debug TicTacToe to it. Now when it does, it again drops me into the debugger. And in the debugger, I can use the same commands as I did before. If I hit L, it shows me that it's about to execute the very first line inside of this Python program. And it will execute these. Now, to execute these things, there's a couple of different options. I'll show you those. But before I start talking about how we can use the Python debugger, I want to show you one more way that we could execute this code. And that is by using Python's Postmortem debugger. Okay, Postmortem debugger. So we talked about using Python, adding the line to the source code and then running it. We've talked about using Python -m. Python also has a Postmortem debugger. The Postmortem debugger is there to allow you to inspect variables after a program crashes. So I'm going to run this program that I've got here, Python debug TicTacToe. When I run Python debug TicTacToe, it allows me to play TicTacToe with the server. So here I can see the computer has chosen position 0A. I will go with the strategic choice of position 1B. Computer chooses 0B, so I'm going to go for the block with 0C. And oh, we've got a traceback error. So I can look at my traceback error, and I can tell a lot from this traceback error. There's some type of a list index out of range error. It occurred on this line of source code. This is the source code where it occurred. That's in line 49 inside of a function called free space. And this is where I called free space, which is on line 56, inside of a function called best path, and this is where I called best path, which is on line 61 inside of computer turn. Right? Wow, that's a lot of information there. But I want to show you how to use the Postmortem debugger. So the way we use the Postmortem debugger is we're just going to run our Python program again, but I'm going to include the -i option. When you run Python -i, that says, hey, when the program is done executing, I want you to drop into the interactive Python shell so that I can run additional commands in the environment. So I'll do this, and again, it just runs my program. I'll use the same selections as last time, 1B, 1N. All right, let's run this again, and I will give it valid locations 1B and 0C. So it crashed again, and this time, instead of bringing me back to the bash prompt, it brings me into Python's interactive shell. So in here, I have all of the variables that exist inside of that function are still instantiated. So I've got a function called userTurn. I've got a function called drawBoard. There's a variable called rows, so I can print rows, and it shows me the rows. I could call a function like drawBoard, and I could pass it rows, and that would execute the code. But I don't want to do that, because at this point I haven't executed a function or anything that actually worked. I want the last thing that had happened to have been that this traceback was generated. And then what I want to do is I want to import PDB to import the PDB function, and then I'm going to run pdb.pm. PM is the Postmortem debugger. And when I do this, it's going to drop me into the Postmortem debugger, and it's going to show me that traceback stack. If I want to see where I am in the traceback stack, there's a command called where. And it shows me, all right, this is the error that occurred. The error occurred on this line, which is in this free space. You'll notice that there's a little arrow here that says currently inside the debugger, we are looking at this line inside the debugger where it executed, which means if I hit L, say list the program, I can see that the arrow is inside of that function called free space, and it's pointing at the line of code where this arrow occurred, where the error occurred. So let's look at where again. I can type up and then do another where, and now you can see that little arrow moved to inside the function best path. So now when I do a list, I can see that I'm inside of the best path function, and I can see that it's about to call free space. So I can use this where and up and then where to step through. Now I should be inside of computer turn list. I'm inside of computer turn. So this is where I called best path. And let's go down and then list. And then this is where we call free space. Let's go down and then we'll list. And this is where my error actually occurred. And I can use up, down, and where to navigate through the trace stack. Some other things I can do here inside of PDB is I can print the contents of variables. So I can type P row, P column, P rows and look at each of these different variables. I could also just type args. If you type args, it'll show you all of the arguments that were passed into your current function. So here inside of free space, I can see that there were 3 arguments. There was a row 0, a column 3, and here's the contents of my rows variable. And if you are familiar with Python, you're probably screaming at the screen, column is 3, column is 3. And each of these lists only has 3 items in it. It has an item in position 0, an item in position 1, and an item in position 2. So this columns 3 is going to be a problem. All right, well, where did columns being set to 3 come from? If I list my program again, you'll notice that the second time I listed it here, the arrow, I don't see an arrow anywhere on my screen. This is because every time you type list, it lists more of the program until it reaches the end of the program, unless you move your stack pointer up or down. So here I'll go up, and then when I list, it shows me best path. When I go back down and I list, then it centers it around the current stack pointer. So here inside of free space, column was 3. Well, where did that come from? Well, it came from a call into free space. So let's go up a func 1 and type where. Now I can see that I am, here's my arrow, I'm inside of best path. Let's list. Inside of best path, I can see this one takes no arguments, so args should be blank. But there's a row and there's a column inside of computer selections. So I can p computer selections. I can take a look at this and I can see the choices that the computer is going to make, and in here there's a 0 and a 3. So I can use this postmortem debugger with where and up and down to step through the functions and see exactly what's happening. Now, the postmortem debugger is just that. It's just for inspecting variables and stepping up and down the stack. I'm going to show you that inside of a program, you can use C for continue to let it run the program, or N for next to execute one line of code. But if I was to do that inside of the postmortem debugger, you can see that it drops me back into the program because the program is already finished executing. So I can't watch the program execute one line at a time from within the postmortem debugger. I can only inspect variables and go up and down. Now you can, let's go back into my postmortem debugger. I'm going to import PDB. I've already imported it. Let's call pdb.pm one more time. Okay. So inside this program, I can call other functions and have them execute. So I could call debug here, and I could say I want to debug a call to let's call debug draw screen, and we'll pass it rows. And it enters a recursive debugger. So the first thing you should always do inside this recursive debugger is do an S, a single step. And it says draw screen. So it wasn't draw screen. What was the name of my function? Let's open up TicTacToe here, see what the name of my function was, because I have obviously forgotten. Oh, draw board. Okay. So let's continue. Okay. Let's go back into my postmortem debugger. Okay. And then let's call debug draw board and pass it rows. Okay. The first thing you want to do here is an S, and then I can list. You can see that you can make calls to function inside of the postmortem debugger using what's called the recursive debugger. And you do that by calling debug, and then you can call functions and watch them execute. But the entire postmortem debugger is all happening after the program has crashed, so it's really not an opportunity to step through the code one line at a time. If we want to step through the code one line at a time, we could do that by using the standard PM or Python -m PDB code. So let's look a little bit more at that. So let's actually not do TicTacToe. Let's step through our Win program one more time, one line at a time. So when I do Python -m pdb, it drops me into my debugger. I do question mark, get a list of all the commands I can do. And we'll talk about some of these here, more of them in the class. Here I can use the C variable. If I type C, that continues. It executes the code. So that executed all of the program, and then it finished, and then it starts back over again. So if I do C again, it'll run my program again. So C can be used to run the entire program. I can also, here you can see that I'm at the first line of the program, use N. N will execute a single line of code, it'll execute until it reaches the next line of code. So if I'm on line 1, if I hit N, it'll execute until it reaches line 2. So I'm going to do a Control L to clear my screen and type L. You can see that now the arrow says I'm about to execute line 2. So I'm going to do N again and an L. Now it's about to execute def my function. Next. I just pressed enter, causing it to run the function, unfortunately. Okay, so let's see where I am in my code. All right, so I just executed total equals my function. I just executed that line of code, which is unfortunate because that's what I wanted to show you. So what I'm going to do now is I'm going to show you a breakpoint, how to create a breakpoint. A breakpoint is where you tell Python that you want to stop on a specific line of code. In this case, I want to stop on line 16 as I'm stepping through this program. So what I can do is I can type break 16. And Python says, okay, I've created a breakpoint, and this is breakpoint number 1, and I've created that on line 16 of your program. So now if I list my program, let's list starting from line 1 and going through line 40. There's not 40 lines, but I can see it shows me my code, and it shows me that there's a B next to line 16. That's my breakpoint. It's showing me that there's a breakpoint on line 16. So that breakpoint, what that means is if I was to hit C to tell it to run the program, it would execute until it reaches that breakpoint on line 16. So let's go ahead and do that. Okay. Sorry, that was finishing the last execution. So now I hit C, it executes, and now it's on line 16. So you can see that my arrow is pointing at line 16, telling me this is where I am. And there's a B there indicating that I've reached a breakpoint. At this point, I can hit N and execute until it reaches the next line of code, which is line 17. Okay. I could also type S. S will execute a single line of code. So S, the difference between S and N is N will stop on line 17. S will execute a single line of code. And since line 16 contains a function call into my function, if I select S, let's open up Debug. If I select S, it's going to step into the function, my function, and I can watch that execute. So you can think of S as step into functions and N as step over functions. So if I type S, it steps into and lets me watch the execution of my function. So here, now that I'm in it, I'll do N to execute a single line of code, and L. It's about to execute win count. So we'll do an N and an L. So now it's executed win count, so I could P win count and watch this variable. I can see its contents. I can P loop count and inspect the value of loop count. I could change the values in these. So if I wanted to change the contents of loop count, I can put an exclamation point followed by loop count equals 5. So now when I print loop count, I can see that it has a value of 5. So we can inspect variables, we can change variables, and we can step through the program one line at a time, watching how it works. Now, what about this print statement? Here I've got this print statement. I'd like to have that type of functionality without actually modifying the code. So how could I cause the debugger to print these things, to print the contents of variables without actually adding print statements? Let's take a look at that. I'm going to go back into my program here, and I'm going to take back out print. take that line back out, and then let's save this program. Okay, and move it back over here. I'm going to go back into my debugger again, okay, and do a list. And I want to watch the variable, the name, as it steps through my code, but I don't want to add print statements. So what I'll do is I'll create a breakpoint on that. I'll create break on line 8. And so now I have a breakpoint on line 8. If I just type B or break, it'll tell me I have one breakpoint that's been created. It's enabled and it's on line 8. Once you have a breakpoint set, there's some modifiers that you can use with your breakpoints. Okay. Once you've created a breakpoint, you can enable special features associated with the breakpoint. Okay. One of those, is that you can tell it to ignore breakpoints. Another is that you can set conditions for breakpoints. And finally, you can set commands for breakpoints. When you create a breakpoint, you can do it by using a function name. So I could say break on function myChoice. And as soon as that function is reached, it'll automatically break. I could also set breakpoints by just passing line numbers, as you've seen. You can also disable breakpoints or clear breakpoints. When you have a breakpoint, you can tell it Python to ignore a breakpoint a certain number of times. So for example, if I have a for loop here that's counting to 10, if I wanted to put a breakpoint in here, but I only wanted it to stop when it got to the third iteration through the loop, then I could create a breakpoint on line 2 and then tell it to ignore breakpoint 1 2 times. And then it will execute the code. When I tell it to continue, it executes through the first 2 iterations of that breakpoint. And then when it reaches the third, it will stop. I could accomplish that same thing by setting a condition on a breakpoint. So using the keyword condition, you can tell PDB when you want it to stop and only have it stop when certain variables contain certain values. So for example, here I said break on line 2, which creates a breakpoint on line 2, this print statement. Then I say the condition associated with breakpoint 1 is that I only want you to stop if the variable I is equal to 2. Now when I type B, it shows me my breakpoint. You can see at the bottom of this breakpoint it says I will only stop if I is equal to 2. Then I hit continue and it runs through, it ignores that breakpoint until I is equal to 2, at which point it drops me into my PDB prompt. Then the last option I wanted to show you that you can set for breakpoints is commands, breakpoint commands. And we'll do this one in the demo. So back over here in my demo, I've got this breakpoint set on line 8. So if I want to associate commands with breakpoint 8, then what I do is I type commands and then my breakpoint number. In this case, I'm setting commands on breakpoint 1. So commands for breakpoint 1. You can see it changes my prompt to COM. And now I can type any Python or PDB commands that I want it to execute when that breakpoint is reached. So the first PDB command I'm going to type is silent. Silent is a special command that will suppress this normal PDB prompt. So it'll make it so I don't see the PDB prompt when the breakpoint is reached. Then what I want to do is I want to print the contents of, I'm going to print the name is, and then the name. Okay. And then what I want it to do is I want it to continue. So when this breakpoint is reached, it's going to not show the PDB prompt. It is going to print the name is and then the value in that variable, and then it's going to continue, meaning don't even stop at this breakpoint. Just start back up. So I associate these commands with breakpoint 1, and then I say, run my program. And when I run my program, it steps through and it shows me the contents of each of the variables, the commands that I've associated with it, step through each of the variables, and I can see how they execute. Let's set a couple of different commands for breakpoint 1. So I'm going to type commands 1, and this time I'm not going to run the silent command. I do want to see the PDB prompt. And all I'm going to do is I'm going to have it print, let's go back up, print the name is and then the name. And then my last command, instead of continue, is going to be end. What end says is I'm done giving you commands for that breakpoint. So now associated with breakpoint 1, okay, breakpoint 1, it's got several commands it's got one command that's associated with breakpoint 1, and that is to print the name is and then the contents of the name anytime that breakpoint is reached. So now I can execute my code, and I can see that it executes as soon as the breakpoint is reached. It prints the name is and then the contents of my variable. I can now list. I can step through the program. If I hit continue, it'll run again until the next time it reaches that breakpoint. And it says the name is Chris. So I can use this as this is the same as doing a P and then the name. Okay? And I can use this to step through and watch programs execute inside of PDB. So PDB is very powerful. I've only started to talk about some of the capabilities that are in there, and we go into this in some more depth in the class. But I've only got 4 more minutes left before I want to take questions from you, and there's one more great way to debug programs that I want to show you, and that is using Microsoft's Visual Code Editor. So this Microsoft, you're on a Linux system here, Mark, right? I know. And the beauty of it is that this is an Electron-based app, and it works exactly like it works exactly like Windows systems on Linux. And this is an excellent little editor, right? So this is a program editor, but it's really more of a full-featured IDE. So here we can see my win function, and if I just pull it up, it provides a nice editor with help as I'm stepping through these programs. And over here on the left, it shows you, this is just a list of different files that I could open. Here I've already opened up this Debug Win program. And let's just go ahead and start debugging this using Microsoft's Visual Code. So I'm going to come up here, and I'm going to Visual Code. Sorry, let me make this not full screen here. Visual Code. I'm going to start my program here. Okay, I'm going to hit F5, which will launch the debugger. Okay, when I hit F5, it drops me into the debugger, and immediately it shows me over here on the left, I can see all of the local variables that are defined on this system. So if I move this down a little bit, I can see that right now it's just got some underscore or dunder variables that have been created. I can see that it's got a little prompt here. I can now use F10 to step forward through my programs. And here you can see it's about to define the variable tote, or it's about to execute this call into my function. I can use F10 to step over the function, or F11 to step into the function. I can also just click these little things. So I'm going to click this to step in to this function, and you can see it's going to define the variable win count. Okay, I can see win count is defined here. It's about to define the variable I. I has a value of 0. It's about to call random choices. I can see the name was set to Mark. It says if the name is equal to Mark, then print win. It's going to print win to the screen. If I come back out to my output screen, I can see that win was printed. You can see that this graphical user interface makes it very simple to step through these things. You also have these watch functions that you can create. So I could come in here and I could add functions that I want to call on different things. So for example, here you can see there's a function called check for winners. And this would be, if I was using that TicTacToe program, I could actually have it call off to check for winners. But let's do something that's relevant to this piece of code. I'm going to come in here. I'm going to add a watch function. Plus sign. And my expression here is I want to look at the length of let's see. I'm going to actually have it print the expression the name equals Mark. I'm going to add this as a watch expression. When I press enter, you can see that it has a value of true. And so now as it steps through these things, I can watch this watch count, and this will be updated dynamically as it steps through the program. I can also hover over the variables. So you can see when I hover above I, 0 appears above it. When I hover on link count, 0 appears there. When I hover over loop count, a 10 appears above it. So just hovering over the variables inside of this little editor will show you the cost of variables. And this is a free program from Microsoft. It's very easy to download and install on your systems, and it'll get you up and running, running a very powerful debugger on your Linux-based systems, even on Linux. And of course, it runs on Microsoft as well. Okay. All right. Some additional things that we can do inside the debugger: you can type restart to restart your program. You can jump to a specific line. And as I showed you, you can use the exclamation point to execute any Python command, such as changing the contents of variables. When you want to get out of the debugger, you just use exit or Control D. Okay. And that is our demonstration on using these tools. I've done the demonstration for you on using conditions and commands inside of debuggers, and I guess we got about 9 minutes left. So, Jason, do you have any questions that have been asked?
No one's really asked any questions so far about the debugger, but what I did want to address is that there was still some audio issues, and it wasn't terrible. What I think everybody was doing is that they were so interested in that they kept listening and they were hoping it would get better. And it did get better times, and then some other times it was a little Max Headroom-ish, if you remember Max Headroom. Am I old? So I think what we're going to do, Mark, is ask you to record this again, and then we'll make the recording available to all the people who have tuned in live. But it wasn't terrible. I was able to follow through, and I think everyone in here was following through the best they could. So I think if people have questions right now, I'll go ahead and write them into the questions block, and then Mark will address them, and we will use those questions hopefully in the recording that we do as well. So your questions are important. Mark, I have my first question for you.
Okay.
What was the name? What was the name of the program? Had to step away and missed that.
What was the name of the program that we used to debug programs? Is that the question?
Yes. Yes.
It is PDB. It stands for Python Debugger. Okay.
And Eric says thanks. I'm waiting for other questions. I have a question for you while I'm waiting for other questions.
Okay.
In your class, and you're doing, is Python Debugger a portion of your class? Is it something that you do after you've taught other aspects of the course?
Yeah, this is something that we do cover in the class after we've covered the essentials of coding. So this is one of the last things we talk about in the essentials workshop in days 1 and 2 before we start getting into developing tools. Let me answer a question that hasn't been asked, but I know it's got to be on someone's mind, and that is Python 2 or Python 3. What do we cover in the course? The answer to that is we cover both. So today there's PEP 394. PEP 394 is what tells us on Linux systems, right? On a Linux system, when I type Python, what does that launch? And according to PEP 394, which is a PEP that's according to Python, right? The guys that put together Python, when we type Python on a Linux system, that's going to launch Python 2. And so for the foreseeable future, we might still have Python 2 being the default Python interpreter on Linux systems. That said, Python 2 is going to end of life in 2020. So in 2020, it'll be like Windows XP, which means it'll only be used to run hospitals, power grids, and other pieces of critical infrastructure. Now, Python 2 will still be around for a long time, but end of life is going to be 2020. So really, we need to be writing code that is Python 3 compatible. So the entire course, we will write programs that can run in both Python 2 or Python 3. So Python 3, Debug Me, TicTacToe will work just as well as Python 2, in which case, they'll both crash because this is intended to be bad programming here on our debugging section here. But all of our code that we're going to write in the course will work in both Python 2 and Python 3 so that you are ready to create tools that anybody who doesn't know the nuances of Python can just type Python, the name of your script, and it's going to run. And it's going to be forward compatible so that when Python 3 becomes the default interpreter, your code will work just fine.
Thanks, Mark. I have a series of questions that have been coming in. Is there a Visual Studio Code for Mac OS X?
So Visual Studio Code is an Electron app, which means it's basically a binary that wraps a web page, right, and with a web page backend, and it will run across platforms. I have not personally run Visual Code on the Mac, but I am highly confident that it is available for the Macintosh as well.
Thanks, Mark. Next question, is there any way to debug a .pyc file?
Is there any way to debug a .pyc file? There is not a good way to debug it directly as a .pyc. Now, of course, there are decompilers. So there are tools that we can give it a PYC and it will turn it into source code .py programs that we can then run through the debugger. Now, you can do some things with the .pyc, but what you're going to be looking at is Python bytecode as you're stepping through that, which is far more complex than actually looking at the code. So if you have a .pyc, the approach I would take would be to decompile that .pyc and then run the source code through a debugger.
Thanks, Mark. Does the Microsoft Visual Code able to debug any programming language?
So Microsoft's Visual Code has interpreters or has the capability of understanding several interpreters. I know it supports PHP. I know it of course supports C#. It supports Node.js and JavaScript. It supports Python. It's got a very rich list of languages that it does support, but I am sure that there are some that it does not.
Thanks, Mark. Are there any cheat sheets for debugging or for PDB use?
No, but I am sure that Jason is going to make me create one because you asked that question. So thank you very much.
That is actually what I was thinking, Mark. Thank you. Any thoughts on using Jupyter notebooks for coding in Python? I think that's Jupyter.
Yeah. Yep, Jupyter. Jupyter is the modern or the most recent implementation of Python notebooks. It's a very rich programming environment. I like it. I like IPython, and the underlying IPython infrastructure on there. I don't introduce it in the course because it's adding layers of complexity that aren't necessary for the core learning objective of the class, which is to teach you how to learn Python. But certainly once you know some Python, jumping into Jupyter is going to give you a lot of benefits in developing code. I generally don't use it for most of the code that I'm doing because I'm not doing a lot of things that require visual output on a web page. I use Microsoft's Visual Code when I'm working on more complex projects.
All right, and then last question, Mark. Jeff wanted to know: is there any difference between the live version of your course and the on-demand version as far as PyWars goes?
No, both the online version, the on-demand version of the course, and the live course have the exact same questions in there. Now, the difference is obviously in the format, right? So in the live class, you've got 6 days, and PyWars is presented as a capture the flag for the advanced users, and one person will get a coin. Now, in on-demand, there is no capture the flag, so there's no competitive version of it in on-demand because, well, everybody starts at their own time and finishes at their own time. There isn't really a group going through it. But the obvious advantage to it with on-demand is that you have 4 months of access to the PyWars server, and you can continue to work through those challenges at your own pace. So while I give you every challenge if you come to the live class, I will give you every lab that is in that book to take home with you so that you can do it at home. When you get back home, you can continue to work through the labs. The capture the flag questions that are in the course aren't distributed. So if you have on demand, then you've got 4 months of access to the capture the flag questions as well, that you could work through those challenges. But those are extra challenges. They're not really part of the course material. They are there to keep the advanced users engaged in learning as they're going through the course.
Mark, I'm going to make time for one more question because it seems important for our forensics friends. In forensics, how do you deal with needing online access for non-standard libraries but working in an offline environment?
And so if I am off, this is an excellent question, and it's not just limited to forensics, right? In penetration testing or any environment where I can't change servers. I need to run Python code on a set of servers, but I can't install modules. I can't control that environment. There are some things you can do where you can, in a machine that is open to the environment, create your programs, and then there's tools such as Freeze or PyInstaller that we can use to create distributed or distributable executables where the modules that make up that script are compiled into and basically put together into an environment that you can move into that environment with SneakerNet or whatever it is that you have available to get your stuff into that system. And then they're self-contained where you can delete that and clean it up quite easily. There's also some modules we talk about where if connectivity is available but internet access isn't, there's some things like remote procedure calls and other things we can use to grab modules from remote systems that we talk about in the class.
All right. Thank you very much, Mark. I'm going to turn it over to Carol to end the webcast. Mark, do you have any final words before we do that?
No, thank you for coming out. I hope this was beneficial. If it was, let me know what types of additional webcasts you would like to see. Was this advanced enough? Was it too advanced? I'd like to hear. Would you like to see more introduction to Python types of courses, or do you guys want the advanced material? So we'd love to get your feedback on the types of webcasts related to Python that you'd like to see me doing on a regular basis. And thank you for having us.
Thanks, Mark.
All right. Thank you so much, Mark and Jason, for your great presentation, which helps bring content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.